All right, Maddie, I'll try and run through this during my parent-teacher conferences, so we'll see how this goes. We may get it broken up a little bit. Um, so, looks like you did number one right here. I'm just going to real quick explain things to you. So, all of these problems, they're giving you x-intercepts for x-intercepts. Um, so they're giving you x-intercepts for all of them. And that means that every one, when you have your x-intercepts, you can write them like x minus, I'm going to use the letter r for my intercepts. R stands for roots, they're also called roots of your equations. And so all of these can be set up like this. This thing just continues like that, depending on how big it is. And notice there's an A out front. And so if you have intercepts, x-intercepts, just like you marked them on your paper there, those give you the factors. You just go x minus, and then it's always the actual root or the actual solution. That gives you the factor that makes up your polynomial. So like the x minus -5 gives you x plus 5, and the x minus 2, it doesn't simplify at all. It just stays x minus 2. And so that right away, when you know your x-intercepts, you can just write your polynomial. The only thing you don't know is a. And I see it looks like you know how to figure out your a value. After you figure out the factors that give you these zeros, by the way, you always check your factors. Like when I get done, I take the factor, set it equal to 0, make sure it gives me -5. So it gives me that point right there. That's how I make sure I have my signs right when I'm done. Um, but then you find the a exactly like you've done here. You take the a, or rather, you take the ordered pair they give you, goes through this point 3, -2, 4. You say, hey, when x is a 3, so you put a 3 in there, I know the y comes out to be -24. And you can't really calculate it and prove it because you don't know what a is. But what it does is give you this equation where the a is unknown, and then you can solve for a. And then it looks like you kind of jumped to this equation. I hope you understand where this came from. So you have to multiply. Your a is now -3 once you find it. So you're doing this three multiplications, -3 times this times this. But we first multiply the binomials. That's that. Surprised I didn't see a little cleanup work here. So first you'd add your like terms there together and then distribute that -3. Now, when you distribute the -3 at the end, it gives you -3x squared, but I think you get a -9x right there. And you also get a minus plus 30 there, right? So this -3, you distribute at the very end to all three of these terms. And so our answer for this one should be the -3x squared minus a 9x plus 30. Now, real quick, there's no way in the world that I would do this problem and spend all that time and then not check it at the end just to make sure I haven't made a mistake. And so you check it if you, as long as you're allowed to have a calculator, you just graph your final answer. So I'm going to graph mine, and I'm going to use f of x notation because this allows me to do something special with it. And I'm just going to put the answer I think it is in there, -3x squared. That's not a squared. I got to get out of imaginary numbers here. We've been working with our eyes lately. You've already done that. -3x squared. See here, minus 9x, I think it is, and plus 30. Let's check those x-intercepts first. Does it cross at -5 and 2? Yep, that's what it's supposed to do. And the other thing it's supposed to do is, oops, slide him out of the way there, supposed to go through that point, 3, -24. So now that I've put it in function notation, I can just ask the equation, what happens if you put a negative or a +3 in there for x? And see, when I put the +3 in for x, -24 comes out. That means it goes to the point 3, -24, just like we wanted it to. All right, so you've got that one correct. All righty. Next one. Go ahead and shoot through that guy here. See if I can get my thing out of the way. So Let's see, a quadratic function in standard form has one of the zeros at -3. So I'm going to put that 0 on there because we're going to use a little tip they give you. The turning point is at -1, -16. So I'm just going to put a point down here and I'm going to call it -16. And it's at -1. So there's my -1. There's my axis of symmetry. And then see, this is the tip they give you. This is 2 points away from the axis of symmetry. The symmetry part tells me I got to have a point over here as well. So -3 and +1 are the zeros for this graph. So here's my general form a x minus root 1 or 0, 1 or x-intercept 1 and x minus root 2. So I go x minus my first solution. I go x minus my other intercept. And so there's the model for my equation with its x-intercepts in it. Now I just got to plug in this turning point, the extra point they gave me. And that point just tells me when x, right, that's my xy ordered pair, when x is a -1. So I'm going to put a -1 in for those x's. My y has to be a -16. So I now just finish out my equation there. Right? All I plugged in was what y would have to be when the x is that number. And now I just do the math here. I figure out what's inside the parentheses first. I get that a alone, so 2 times 2 is 4, but it's a -4, and divide by the -4 on both sides, right? That gives me my a value, +4. So there's my equation. It's this guy, the simplified one, but now I know what a is. A is a 4, so I go y equals 4, x plus 3, x minus 1. And that's your answer. Now, if he wants it in standard form, that's when you take the two binomials, multiply them together. I'm going to clean up the inside there, so I add my like terms, that's 2x's. And I distribute the 4. 4x squared plus 8x minus 12, right? I take the 4 to every single term. And so there's your equation. I said, hey, if you're going to do it, check it. All right, so let's check this guy. Get my thing up here. So there we go. Uh, so I'm going to delete all that stuff. Just put my new answer again using that y notation or that f of x notation. There we go. Does it have the right intercepts? Yep. 1 and -3. Does it go through the point they want it to go through? The f of, see here, they told me that if I plugged in what was the problem? A -1, I get a -16. I'm going to plug a -1 in, and I better get out a -16. And I do, so I know that's the correct answer. I'm going to pause it, go to a meeting.